Yes, Soumya, you can start.
Good afternoon, everyone. We are here for the webinar on behalf of IIHMR Bangalore, a webinar on prompt engineering for healthcare business analytics. Our speaker will be Mr. Vinay Sir. He's an assistant professor for the health IT management at IIHMR Bangalore. I'd like to take you all on a tour what exactly our institute is. Institute of Health Management and Research, Bangalore. It is one of the leading and premier institutes, business schools in India. Can we change the slide, sir? IIHMR was established in 2004, and it aims to provide leadership and competency building among health or hospital managers, planners, decision makers, trainers, and research scientists at national and international level. IIHMR offers 2-year full-time PGDM program in 4 specializations, that is hospital management, healthcare information technology, as well as pharmaceutical management. It also offers 2-year full-time PGDM program in artificial intelligence and data science in healthcare, and it also offers 3-year fellow program in management. Let me take you through the milestones IIHMR has achieved. IIHMR Bangalore was established in 2004 as a South campus for IIHMR University, Jaipur. We got our NABET accreditation in 2015. We received our MBA equivalency of the program in 2018. Admire, a Center for Advancing Digital Healthcare, was launched in 2021. And this year, we are launching a new program, a 2-year full PGDM program in AI and data science in healthcare. Can we change the slide, sir? IIHMR has 5 key verticals, that is academics, research and publication, training, consultancy, as well as Center for Advancing Digital Health, that is Admire. In academics, we offer PGDM program, fellowship in management, as well as executive program in hospital management. In research and publication, we focus projects which are evaluative, formative, implementation research, as well as social assessments, with our thrust areas in NCD, health communication, digital health. In trainings, we provide MDP, FDP, certificate programs, professional practice sessions. We are also equipped for in-person, virtual, and hybrid programs. We also offer consultancy on individual and institutional and faculty level. We offer NABH consultancy for quality management, growth and strategy, as well as project impact assessment. Admire is a Center for Advancing Digital Health, which mainly focuses on medtech testing and skilling hub. It also focuses on digital health data and AI development. It is also our institution's innovation cell. Can we change the slide, sir? As I have mentioned, academics. In academics, we offer courses. The curriculum is based on industry requirements. It is the right mix of industry, academia, and industry interface. Our placements, we have 100% placement record in over 90+ organizations, and we offer 360-degree career guidance. Next slide, sir. Our courses is approved by All India Council for Technical Education, that is AICTE, NBA accreditation, as well as the Association of India Universities MBA Equivalency Award. IIHMR is awarded and recognized globally as well as internationally. We have been awarded gold band grade in out-based education ranking by World Institutional Ranking in 2023. IHMR is 10th rank among B schools in Bangalore by the Week B School Ranking 2022. It has secured 7th rank among B schools in Bangalore by Outlook B School Ranking 2022, and it has other recognition and awards as well. Can we change the slides? IHMR also empanels with national as well as international organizations such as Jal Jeevan Mission, NHSRC, National Health Authority, as well as NABE. In research and publications, our expertise are in evaluation, formative implementation, research, social assessments, and policy research. We collaborate with UNICEF, WHO, ICMR, as well as NHSRC and HCL Foundation. In trainings, we learn and develop. Our categories are MDP, FDPs, certificate programs, professional practice series, with areas where we focus on healthcare quality, health and nutrition, digital health, public health, as well as health insurance. As mentioned earlier, Admire is a research and development hub where we focus on digital health as well as AI. We have institutional level consultancy as well as faculty level consultancy, where on the institutional level, we do NABH consultancy with our key areas in growth and strategies and project impact assessments. These are our intellectual capitals at Bangalore: Dr. S.D. Gupta sir, Dr. C.S. Kedar sir, Dr. Usha Manjunath, our professor and director, as well as Dr. S. Sadagam. Thank you. This was the introduction. Now I would like to invite Dr. Pankaj sir, our professor at IIHMR Bangalore, for further elaboration of our new program, that is PGDM in AI and data science in healthcare.
A very good afternoon to all. I am Dr. Pankaj Rahi, Associate Professor at IIHMR Bangalore. So I'll speak on the related new program which is being launched by the IIHMR Bangalore, that is PGDM in Artificial Intelligence and Data Science in Healthcare. This is one of the pan-India program which is being launched by the IIHMR Bangalore, which it is a 2-year full-time PGDM, offers various learning related to the artificial intelligence and data science technologies. Next, please. Since IIHMR, the IIHMR is one of the premier institute of India and started in 2004. It offers various courses related to the healthcare management, health IT management, artificial intelligence and data science, and hospital management. Next, please. Since IIHMR have many milestones, achieved the many milestones like a premier institute of the India, it has better outcome-based education. It has a better 5,000 alumni base all across the world, international and national collaborations. Next. We offer the courses like PGDM in hospital and healthcare management. It is also a 2-year flagship program. The new program which we started this year is PG Diploma in Management, Artificial Intelligence and Data Science in Healthcare. We have a fellowship program in management. It is a doctoral level program. And other executive program in hospital management under Center for Learning and Development. Next. So the PGDM, Artificial Intelligence and Data Science, is a 2-year full-time course offered by IIHMR Bangalore. And this course focused on predictive analytics, machine learning, deep learning, and other technologies which are being required in this current era. This course endeavors to cultivate the new generation of the healthcare innovators, poised to harness the transformative power of AI and data science for betterment of the patient care and the advancement of the healthcare system globally. Next. The eligibility of this course is we offer this course to the bachelor or master degree students who are graduating from engineering discipline, computer science, computer application, information technology, science, statistics, maths, and commerce economics. Other than that, this course is also offered to the medical or allied medical graduate, BDS, and BMS, MBBS, or postgraduate degree in allied health sciences, which should have passed the +2 level with maths, computer, or statistics, etc. as the one of the subject. Other than this, if candidate has passed the state level CAT, MAT, GATE, or KMT or similar examinations, are also eligible for this course. Candidate with working experience and defense person are also encouraged to seek admission in this course. The selection process, this course contains total 30 seats approved by the AICT. All admission process is scheduled as per the AICT norms and their guidelines. And on this fulfilling of the essential qualification, candidate is sorted for group discussion and personal interview, and its grading will be made from out of 200 marks. This course fees is 10 lakh, and we have a more than 1 crore scholarship under this program as per the institutional policy. Next. As said by Dr. Shea, the legacy of the IIHMR Bangalore is it is the first premier institute in India who started healthcare management course, first in India who started PGDM, artificial intelligence and data science. The faculty resources and course structure, it has a renowned faculty and academia and industry link, interactive sessions through the professors from IIT, NIT, and IIM, course created with the right mix of the classroom and the industry immersion programs. In infrastructure, we are having a Center of Advanced Digital Healthcare, Center for Advances Digital Healthcare, we calling it as ADMIRE. We have a equipped digital data and AI lab, robust research and development hub for digital health, interactive classroom, and a state-of-art library. We offer a strong alumni base in the digital health space and network with the other institutions. The Center for Advancing Digital Healthcare, ADMIRE, offers digital and AI lab, sorry, just a minute. Next, it offers skill hub, digital health and data AI lab, incubation cell. It is also offered under this ADMIRE center. Next. The course structure is orally containing of 4 terms. In the first beginning, we have an induction course, we have a foundation course, and then the term 1, we offer the data science for healthcare. In term 2, we offer digital health product development and summer training program. In term 3, we are offering artificial intelligence and healthcare. And then in term 4, we are offering finance and specialized application of AI and data science for healthcare. Next. And dissertation is also at the end. We have a very good international national collaboration. We are having a BOSS Global Software Technology with as a collaborating center. We have a Maastricht University, University of Massachusetts, University of Oslo, Vivekananda Global University, and other pioneers organization working in the healthcare, digital healthcare, or IT domains. Next. Moreover, as I said, we have a 5,000 plus alumni base. So our alumni are placed in various part of the globe and working in the various domain like healthcare domain, hospitality industry, and public health domains. As per the faculty and intellectual capital of the IIHMR, we have a alumni and a trustee secretary, Dr. S.D. Gupta, and John Hopkins alumni and a professor. We have a Dr. S.D. Sadagopalan, visiting and distinguished professors from director and former director at IIIT Bangalore. We have a retired Dr. C.K. Kedar as a senior advisor, and we have a director, Dr. Usha Manjuna, as a present director. We have other professor and associate professors working in the institute along with a team of good faculties and assistant professors. So I request the candidate, whosoever is willing, who want to know more about the course, they can contact in these numbers or can contact the admission cell of the IIHMR Bangalore. Next. Thank you. Now, I'll share. I request Shreya to take further. And one more announcement I want to make it in this webinar. We are placing some question as a quiz, and so can respond to it. And other than that, all are requested to don't leave this session, because at the end of this session we are going to place a feedback link, and kindly submit the feedback so that you will get a acknowledgement as a certificate. Thank you. Shreya, please.
Now I'll request Mr. Vinay sir, an assistant professor at IIHMR Bangalore, to start the program. Sir has over 4+ years of experience in machine learning, optimization, NLP, data pipeline development in healthcare domain. Sir has completed his MTech in machine learning and intelligent system from IIS Bangalore. Sir has experience in machine learning model building, health units optimization, manpower optimization, supply chain optimization, data pipeline development and deployment, sentiment and semantic analysis, and spatial dashboard development. He has also worked with Department of Family and Health Welfare, Karnataka, as well as PPMS department that from Government of Karnataka on various projects related to data science and science application during his time at Public Affairs. Over to you, sir.
Yeah. Hi, everyone. So good evening. So today I'll be speaking regarding how we can sort of use prompt engineering in healthcare sector. So I'll just be sharing across my screen. So coming to the initial topic, as in what is the domain that we are trying to address here. The domain which we are trying to address is healthcare business analytics. So healthcare business analytics involves two aspects. One is the data as well as the quantitative analysis which can be done on the data to determine how we can improve the efficiency of the operations which happen in the healthcare sector. So coming to the importance, it's important to analyze this data and get the results out of that, because it enables us to take a data-driven decision rather than taking a decision without any backing of data. It enables this analysis helps us to take a data-driven decisions. It can improve patient outcomes, as in reducing the morbidity and mortality, and it can reduce the costs also. in terms of operations, we can reduce the financial costs which are involved. And in terms of increasing efficiency of maybe providing the service to the users, that also can be optimized. And it also can optimize the resource allocation, such as where the units hospital should be located, what services they should provide, and also where the manpower should be located and how it should be distributed. So coming to the various techniques which can be used for healthcare business analytics, there are three main techniques which can be used. One is descriptive analytics, and other one is predictive analytics, and the third type is prescriptive analytics. So coming to the descriptive analysis techniques, it provides insights into what has happened in the past. So this can be either through sort of central limit concepts such as mean, median, or it can be through various charts or plots which are possible, univariate and multivariate plots, and maybe tabular summary can also be generated. Coming to the second type, it is predictive analytics. In this type, we would sort of use forecasting techniques or statistical models to identify what would happen in the future and predict so that we will be having an idea what would come in the nearby future. So examples of this include disease outbreak at the community level, or estimating the risk of a person sort of having maybe developing a certain disease, which would be an example of a classification predictive analytics. First one being a regression predictive analytics. Third type is forecasting maybe admission rates in hospital, or maybe forecasting the drug consumption in a supply chain is involved. That would be also another example which can be given for predictive analytics. So coming to the third type of analytics, this is prescriptive analytics. This goes one step beyond the predictive analytics, wherein we'll not only predict what would happen, and we would also suggest that what would be the optimal inputs which should be given, or what would be the optimal steps we should be taken to obtain a desired results, whichever we need. So here, the example of prescriptive analytics would be various techniques such as optimizing of units, as in where the hospital should be located in terms of public healthcare. It might be primary healthcare center, or in case of a patient, it might be patient satisfaction can also be sort of optimized to select what services we should provide. And also manpower allocation is another example, and supply chain optimization is also another example of prescriptive analytics. So next one, we'll be having 3 MCQ questions actually. You can answer them in the chat so that whoever answers the quickest is sort of will be getting a prize at the end. There will be 3 MCQs and you can send it in the chat, whatever is your response. So I'll be going to the first MCQ question, and throughout the session, the other 2 will follow up. So this is the question. The first question is, forecasting patient load at a hospital belongs to which type of analytics? Option A is descriptive analytics, option B is sentiment analysis, option C is predictive analytics, and option D is prescriptive analytics. So I'll be giving across 1 minute, so you can share your responses. So I see most of you have answered. So I'll be going to the next slide. So coming to today's topic, which is introduction to prompt engineering. Prompts are especially what are the inputs that we give to the AI model so that it responds in an ideal manner, however we require the functionality. So prompt engineering involves crafting of inputs, which is prompts, that guide AI modules, especially the natural language processing models. These are NLP is those models which sort of helps us to communicate in our language with a computer system or an AI model. So to generate a desired output. So it's also about the main challenge here is that we have to communicate in an effective manner to obtain the desired results, or else we will be obtaining the results which we don't require for our application. So prompt engineering plays an important role due to the following factors. For example, it's important as it's central to improving the model's interaction, as the model understanding depends on whatever the inputs you give. It's efficient if we give the proper input so that the model can give a proper output. And also giving an efficient prompt design would also reduce the complexity, as in the overhead or the time required for the model to respond would sort of be more efficient, and you can get the results faster rather than in multiple steps. You'll be able to obtain in fewer steps. And also it's critical in applications where precision and accuracy is important, as in if you don't give the proper prompts, the model might not be able to respond with precision or accuracy. which is sort of will lead to difficult situations. As in healthcare, the accuracy is one of the important parameters. So it's important that we give a proper prompts. So coming to the history of prompt engineering, there are 4 phases which are shown here. Initially, it used to be rule-based systems, wherein in the original days, there used to be specific rules which were there, or templates which used to be there, that if that specific phrases come, it would respond in a specific manner. Later on, during 1980s and all, there were SVM models and decision tree models, which were machine learning models, as in there were less of these templates which were used, and rather than that, a model was sort of trained based on the inputs which are given and outputs which are there. Rather than giving specific rules, the model would learn the rules on its own. And post that, around 2000, there were NLP models which were built, which is natural language processing models, which allowed the communication to happen in an efficient manner, as it started building applications such as sentiment analysis, machine translation, and deep learning was also evolving during that phase. And the 4th phase is that where large language models started to come, wherein we would give the certain aspect of a sentence, and the next part of the sentence would be predicted, or the next word would be predicted by these large language models using the huge language data set was given. And this was around 2017 where it started revolutionizing. So coming to the steps of prompt engineering, there are 6 steps which are there. First step is to define the objective, and this thing we would understand what is the goal or we need, and based on that we would define what the prompt should achieve. And after that, we would identify what are the requirements and the constraints of the model which should be taken, such as it might be accuracy, precision, specificity, and the complexity or the time by which the model should respond. Coming to the second step, which is to gather and analyze the training data. If there is some data set involved, such as it might be an image which we might give to identify certain factors, or it might be an Excel or a CSV data which we might give, or it might be an audio file, or any other sort of unstructured data or structured data can be given. So this should be sort of taken in this second step. Once that is done, next step would be to design the initial version of prompts based on our objectives and the requirements. So once we give our initial prompts, next step would be to test and evaluate the model performance in various scenarios and giving different input variations or different training data sets. Once that is done, next step would be to evaluate the performance of this various sort of test data sets. And if we are satisfied, we should sort of freeze the model or take that as a final prompt, which is sort of most optimal. Once that is done, we would optimize, and we would also ensure that the model is scalable and it works well on across different data points, which is not used for maybe training the prompts. Once that is done, next step would be to obtain the feedback. If it's live stream, to obtain how we can enhance based on the feedback which is obtained from the users. So coming to the technical foundations which are there behind prompt engineering, one of the basic technical foundation is natural language processing. As I said before, it's a branch of AI which deals with interaction between computers and humans through a natural language, which might be English, or it might be any other local language if it's built on that specific local language. The ultimate objective of NLP is to sort of read the data which is there and decipher it and understand what is it and make sense of what the user is they are trying to tell based on the context of the task. NLP tasks encompasses various range of applications. It can be sort of used for machine learning, machine translations, as in if there is specific language text which is there in English and you have to translate it to maybe a foreign language or the local Indian language. That's also a possible application of NLP. The other one is text summarization, wherein we might have huge PDFs of clinical notes or data, and maybe a doctor would not have so much time to go through them. It would sort of summarize what is the essential points and give in brief what is required. Other one is other application is sentiment analysis, wherein we would be able to, for example, if a hospital is there, we would be able to identify how the hospital is performing on various aspects. It might be based on cost or quality or wait time, other aspects whichever we define. We will be able to measure how it's performing on each of the aspects so that we can improve the operations. Other one is speech recognition. This can be in terms of maybe virtual assistants which can be used or voice bots, wherein we would give specific audio data to the model and it would process that and generate the specific outputs based on the input given. Last application which I have stated is text generation. Here it can be sort of, we would give a small sort of text input, or maybe we would be able to generate text data based on various input data which can be given. It can be either through a paragraph is given, it will be able to generate the whole document, or a video is given, and based on that video, it would be able to generate a text, or it can be image to text. That way, text generation is also one of the application of NLP. So coming to the further technical foundation for prompt engineering is LLM. LLMs are large language models, as I said before. These are AI models which uses deep learning techniques, which is sort of a neural network, which would have an input layer and also a hidden layer where mathematical computations happen, and also an output layer based on the requirement of maybe it's a classification or continuous data that we have to predict. So this deep learning models would be there to sort of based on these deep learning models, we'll be able to understand and generate human-like text. So these models are built on vast amount of data sets, and they learn what is the pattern of data, as in the sequence of how they appear, and the grammar, maybe the syntax of the language which is there, and also the context, as in the semantics or the meaning of that specific words which are there. The architecture behind modern LLMs is a self-attention mechanism, as in we would analyze what is the impact of each word in a sentence with respect to the other words in the sentence. So it would be which words are important in a sentence and which words are not important. Based on that, the model would understand what it should predict next. So LLMs are typically pre-trained on general tasks like predicting the next word in a sentence, or maybe given a sentence, predicting the next sentence, and then fine-tuned for specific applications using smaller data sets. So through this training, LLMs acquire various abilities. It can be like understanding the human language in terms of grammar, syntax, and semantics. And generating text is also a possibility. And we could also give different writing styles and creative formats can be given. And also translation is one of the applications wherein it would be able to generate creative contents and answer the questions in an informative way. So coming to various elements of prompts, the various elements include the instructions which we give to the prompt. It's the verb or the action which it should do. For example, we can ask to write a poem, or it can be open-ended prompt like explain the concept of gravity. Next element of prompt is the context. Providing a brief background or history to the prompt sort of helps set a scene, or it sort of sets a scenario wherein the prompt would have proper idea what has happened and what it should do based on the instruction given. And coming to the third element is the input data. For example, there might be some input data which we have to feed, which might be unstructured or structured data, as I told before, for working of the model. The next element of the prompts is exemplar. This is an optional thing. For example, there's one of the type of prompting called as few shot prompting, wherein we would provide a few examples, as in how is the desired task, as in we would give the input and also the output what the model should predict. And this whole training data is given to the model to predict on the new data. The next element of the prompt is output data. For example, we might specify also the style of the output which we need. It might be that it should generate an image in JPEG format, or it might be that it should generate an output in PDF, or a video it should generate. That also can be given, and it's one of the basic elements of prompt. Last element is the tone. This indicates the emotional tone of the output. So whether we require it for an informative purpose or persuasive purpose. For example, few of the prompts would give the research studies which are done, so that users would have an idea why it's generated, and also it can be humorous tone for enjoyment or joking purpose. It can be also used. So that should be that can be specified using the tone element of prompt. So coming to the basic prompt structures which are there are two types of basic prompt structures. One is a closed prompts. These are sort of type of fill in the blank prompts, wherein we would give a mask, as in there would be a blank space which is there along with the sentence, and the model based on the input sentence which is there, it would predict what is that blank statement. For example, here we have given the capital of Francis, and we have given a blank to the prompt or the AI-LLM model. So the model would fill it as Paris. And the other type of prompt is a prefix prompt. Here we sort of provide the beginning of a sentence or a paragraph, and the prompt sort of completes the whole sentence which is there after that. And this is the open-ended prompt. First one is a sort of close-ended, wherein we fix what is the output, and second one is an open-ended prompt where it gives more creative freedom to generate. For example, once upon a time, if we give and tell it to generate a story, then the model would be able to generate a specific story based on the initial sentence which is given. So coming to the types of prompts which are there are two types of prompts mainly. One is manual prompts. These are sort of mainly given by human experts, and they are created by individuals who have deep domain expertise and also an idea about how that AI model works and what context it can be used. So this requires human intuition as well as creativity. Second type of prompts are automated prompts. These are generated through algorithms. For example, if you have to build a software project, the prompts will be able to generate all the sub-steps or sub-prompts which is there within it by itself, rather than we sort of giving it what it should do through the next steps. So among manual prompts, so there are two types of manual prompts which are there. One is the zero-shot prompts, wherein we would not give an example, and other one is a few-shot prompts. So manual prompts are, as I said before, these are crafted by human experts, and the characteristics include since it's given specifically and it's sort of narrowed down, the precision and specificity or the accuracy of this would be more better compared to the automated prompts. And often they're used in scenarios where there is understanding of the domain is sort of more crucial. This is sort of used. Example of this includes a researcher asking an AI to analyze the trends. For example, a correlation between carbon emission and what is the temperature increase between certain years sort of can be analyzed. So coming to the first type of manual prompts, which is zero-shot prompts. So these are sort of prompts which require the AI we need not give any specific example or training data set to sort of predict what would happen. Here, the AI solely depends on the pre-existing data which is there, and also its generalization capabilities. Characteristics of zero-shot prompts include there is no task-specific training data which is needed as it would, and it also relies on the AI's generalized data which is there already in the data set. Example of this includes what is the environmental impacts of deforestation, as in we have not given an example of how it should respond. Coming to the second type of manual prompts, it is few-shot prompts. Here, few-shot prompts provide the AI with small number of examples, or these are called shots, before requesting the prompt to perform certain tasks. These would sort of give an idea of what format of output the prompt should generate. This can also be called as example tasks. And these examples serves as a guide for the AI model to sort of understand what should be the context in which the inputs are given and what is the expectations from the model. Characteristics include uses a limited number of training examples and also balances this sort of prompts balances between zero-shot prompts where there is no training data involved to obtain an output, and also using the full training data. Example of this sort of prompt is giving an AI module 3 examples of maybe summarizing a short stories and then asking it to generate a new short story. So coming to the second type, which is automated prompts. Automated prompts, as I said, are generated by either systems itself or algorithms without human intervention each time, rather than the manual prompts, where in each step we have to sort of intervene. This can be based on the templates or dynamically constructed by AI depending on the context. There are two types of automated prompts which is there. One is discrete prompts and other one is the continuous prompts. The advantages or characteristics of automated prompts are that it is scalable and it's also efficient, as sort of with huge data sets coming, we need not sort of manually handle these things. The model would be able to handle on its own as the data sets keeps coming. So the scalability and efficiency is also addressed. So it might lack the specific sort of domain expertise, but they are sort of faster and also cost effective, since there's no domain expertise cost which is involved. Example of this includes a customer service chatbot, wherein we can sort of initiate a conversation with it as how may I assist you today. Coming to the two types of automated prompts, the first one, which is discrete prompts. Here there is concise instructions which is given to the AI and that response is obtained. For example, that Google might provide the chatbot which is there, and there will be specific responses which you can select among the options. You can't give other than that whatever is given within that. So these are sort of example of discrete prompts. These are highly structured or they have specific templates and are often limited to specific tasks. And they're also designed to obtain precise, so they will give precise outputs and predictable responses are obtained. Example includes in a customer service chatbots, discrete prompts are used to guide the users for predefined options or solutions. Second type of automated prompt is a continuous prompts. These are dynamic and ongoing dynamic sort of instructions which are there to query from the user. They guide the AI response throughout the session rather than being a limited one or a single interaction won't be there. And there will be continuous step-by-step interaction, and it, as the characteristics points out here, the conversations will evolve and the previous context is also taken into consideration to build the next prompts. And it's designed also to maintain the fluid and engaging interactions, as in there would not be restricted to give specific inputs. And example includes the chatbots or customer service agents, where the conversation does not follow a fixed path, but adopts as the user ongoing inputs are there. So maybe a text box would be there and user would be able to give feedback, and chatbot analyzes that text data which is there, which is not a standard template, and gives the response. So coming to the second question. So the second question is as follows. Which of the following is not typically considered a basic element of prompt used in prompt engineering? The first option is the desired emotional tone of the output, whether informative, humorous, or persuasive. Second option is starting text, images, or data points that serve as a foundation for generation. Third option is how quickly the algorithm processes the input. Fourth option is optional examples provided in fusion prompting to guide the model response. So which of them is not a basic element? So you can answer the options in the chat. Great, a lot of you are answering it. So okay, since we have obtained a lot of responses, I'll be going to the next slide. So coming to the application of prompts in healthcare, prompt engineering enables large language models to achieve wide range of tasks in medical fields with high response and accuracy. With customized medical prompts, model can accomplish tasks which were previously sort of difficult as there were huge data sets and also there was resource constraints. So coming to the various applications, they include classification models, as in we would be able to classify which class or what is the output, or maybe if I give an example, whether the person is diabetic or not, whether he's suffering from certain disease or not. And next one would be generation, wherein we could sort of use prompts to generate the medical text data, which is sort of being challenged and there is scarcity of data previously. The third application includes detection, wherein we would be able to identify the medical text which is there among the whole text, or maybe identify certain aspects of maybe certain diseases in medical imaging data can be detected. Fourth application includes augmentation, wherein we would be having a current data set and the data set would be small to train the machine learning models. So due to that, we will be able to augment the data based on the distribution of data which is currently there and generate the new data sets. And last application is question answering, wherein we would be able to give to the bot various questions. It might be in terms of images or text or audio, and the prompt would respond based on the system which is trained. So I will go through each of the applications which I have mentioned in the previous slide. The first application is machine learning classification. So these are models which are sort of trained on labeled data sets, as in there would be inputs, and for each input there would be a specific labeled output or a class which is there. The model would learn the mapping between the input as well as the output, and the relationship is sort of built into the model. This sort of helps to sort of predict on the new unseen data if it's presented to the model. It would predict what class it belongs to and what are the features which is sort of contributing highly to the outcome. So coming to the applications of prompt engineering in classification models. So the first application which I'll be discussing is regarding medical image analysis. So researchers have built a model called as GPT-4 MIA, which incorporates generative pre-trained transformers for medical image analysis. So this is a specialized version of pre-trained GPT models, which is designed to understand and process medical images and translating complex visual data into actionable medical insights. So for these models, we would not only give the image as well as along with that, we would give the text data so that the model would be able to predict more accurately. So the purpose of this model was developed to enhance the accuracy, efficiency, as well as specificity in diagnosing medical images, which can be either in terms of X-rays, MRIs, or CT scans. Example of this type of analysis includes a radiologist. You would give a prompt like identify and measure any pulmonary nodules present in the following CT scan, considering the patient history of smoking. So here, apart from the image which is given, it's also a prompt is given which sort of gives the patient history or patient features, wherein it tells in this case, patient history of smoker. Smoking is also taken as a token to sort of predict what would be the outcome. So coming to the second application, which is clinical text classification. As you can see in the table, which I have added on the right hand side, which sort of gives the prompt template and the type of the prompt which is there. So here we would be giving the text data as in the input data clinical notes which is there, and based on that clinical data, we would be predicting what this is. So the mask is what the model predicts here. And in the second row of the table, we can see the text data or input data is given. This affects what? And in the third one, we can see text as well as mask is there, which the model would predict and what is ordered. So this way here, the model which is sort of built is health prompts and it's based on the clinical NLP data framework. The key features of this is that it does not require any training data, as in we can give a 0 prompts, and thereby we can give the unlabeled data to the framework and it would define what is the label of the data set. The purpose of this was to design a classification model wherein clinical text can be used without any training data, as training data is challenging to obtain as well as labeling takes a lot of time and cost. Example of this includes the patient has cough and expanded chest that does not deflate when he exhales. This is a symptom of what the model predicts what is the disorder that is suffering. So coming to the last application of classification model, which is mental health classification. So here the researchers had used ChatGPT model to sort of classify whether the person is suffering from a stress or is not stressed. And for this, the data set which they had used was social media posts, and they had used it for detecting stress and depression as well as suicidal detection. The model also demonstrates strong capability in classifying the data set without prior any data set, labeled data sets, as in it's a zero-shot training. So coming to the second application, which is data generation. So prompts can be used also for guiding the AI module or the LLM model to sort of generate new data points in case of shortage of data sets or non-availability of data sets. So we can specify the desired format in which we require the output, and also we can give the context or content can also be given, and even the style of the generated data can also be determined by the user. So this allows to create a data sets which is sort of having similar distribution as the training data set. For both the training and testing purposes, we can use the data set. And the AI modules can use these prompts to generate synthetic data sets, especially where real world data set is sort of very short in number or is sensitive and it's not available. So coming to the application of data generation using prompt engineering. So the application that I'll be mentioning here is medical text generation. Right side, we can see an example wherein there is a complex medical abstract which is there, which includes several statements which are there, 7 statements which are there. And the model based on this medical data which is given would sort of summarize what are the key phrases which are there. It would identify what are the key phrases. Those are marked in bold, you can see. We included trials. That way it's marked in bold. Whatever are the key phrases. Those key phrases would be taken and given to the next level model wherein it would give a plain language summary of whatever the text which is there. So this model is named as NAPSS. The researchers have named it as, and introduces the summarize. Initially, it summarizes what are the important words, and then it simplifies into a small plain English sort of text. The purpose of this model was to generate summaries to train the models based on the key contents and also extract the key contents. And it uses narrative prompts to guide another generator to clarify the text, and it also is good in maintaining the flow of text generation. So coming to the second application of generation, here we are sort of looking at medical report translation, and the authors of researchers have used ChatGPT for translating the radiology reports which are there into plain language so that it can be sort of even understood by various levels of audience. So the purpose was to generate both general and specific recommendations based on the reports data which is there for various levels of audience. Example includes, please translate a radiology report into a plain English for a patient only with undergraduate education. So based on the various audiences which are there, we would be able to tailor make the reports so that it would be more sort of, we would get a context of what is happening. So coming to the third application, which is detection. Detection prompts are sort of instructions which are given to identify the specific entities or anomalies or outliers in the data which is there, or the conditions within medical data. It can be either image, video, text documents, or any sort of other unstructured data. This application guides the AI model to focus on its analysis on particular areas of features which are clinically relevant, thereby aiding in the diagnostic process. Benefits of these include improved accuracy and also early detection of disease, thereby reducing the workload for radiologists and also medical professionals. And third benefit includes potential for personalized medicine approaches. So coming to the application of detection, so I'll be explaining regarding medical text detection. Here, DID GPT was used, which is de-identification GPT, the modern name was, and it was used to de-identify the medical data, thereby ensuring the privacy as well as preserving the context which is there in the sentence. So the purpose of this model was to use prompts to generate optimal de-identification results with minimum human inputs. So for example, we can see that there was an original medical text data where patient John Smith, a 42-year-old, and this sort of a case history is there. And we also have the DID GPT, de-identified GPT output, wherein the patient John Smith, whatever his name was there, was recognized by the model and it was replaced by ID, and as well as his whatever readings was there, it's also anonymized that by placing a star at the end of it. So coming to the next application, which is augmentation. Data augmentation involves expanding the available data set which is there and creating the new data points from the existing data set which is already there. This application improves the robustness as well as accuracy of the models, as in if we have more number of data points which is there to train the model, it would increase the accuracy as well as the robustness and performance of the model. And it also, the privacy concerns are also sort of limited since it can create an anonymized augmented data. This also ensures that the generated data is consistent with the semantic properties or the properties which is already existing in the data, thereby also maintaining the accuracy and relevance of the dataset which is generated, augmented. Benefits of using augmentation prompts are as follows. It enhances the model training, as I said before, by giving a wide array of scenarios and generating the datasets. And it also reduces the overfitting as more data points would be available, and it would sort of, instead of learning the specific aspects, it would sort of generalize the learning and it aids in learning the underlying patterns which are there. And also it's cost effective since there is not much time which is sort of used or cost which is involved in training or labeling the datasets and also building these datasets. So coming to the application of augmentation. So I'll be explaining regarding the text data augmentation. Here the authors have built a model, the researchers have built a model called as StratAug, which is a new text augmentation database, and it uses ChatGPT. So here we could see that the sentence is there and it would rephrase the sentence which is there in the training dataset similarly to whatever the sentence which is there, but slightly with different rephrasing patterns. And it also enlarges the sample corpus which is there in the training dataset, as I explained before with the benefits. So here, for example, there is a original text which tells the follow-up rate after 5 years for a certain disease was 85%. And the altered text includes the 5-year follow-up rate was found to be significantly high at 85%. So this way the model would generate various augmented text datasets, which is having a similar context or meaning as the original text which is there. So coming to other application of augmentation. So researchers have also built a model called as MediMP, which tells that medical images and prompts using multimodal learning model. In this, for example, we could see that generate a clinical note describing the patient's response to the current diabetic medication based on the following glucose readings and dosages. So the data set would be there in the table and the prompt would be given as an additional input. So both the tabular data and the text data would be used to generate the new augmented data. Coming to the next application, which is question answering. Here, the application would be to pose questions to the AI model to search, comprehend, and accurately respond based on the knowledge database which is there. And these models also need to ensure that they are not only technically proficient, but also provide relevant and correct medical information. So applications of these include medical image-based Q&A. For example, here there's a new knee joint image which is there, and the author is asking what are the abnormalities in this knee image which is given. So the ground truth or the original labeled based on the radiologist would be fracture on the left radius head, and the model also predicted the same output. So the purpose of this was to enable the model to understand medical images for visual Q&A tasks, where answers are not only limited to the predefined options. So coming to the other application of Q&A, which is medical video-based Q&A, here we could see that the question or the prompt is that how to examine lymph nodes in head and neck. So the author would give text data and the model would respond by generating the text video for the text data which is given. So VPTCL, it's called Visual Prompt Text Span Localization, as in the text would be mapped to specific sections of the video, specific images, and later the video would be built based on the images which are generated. The purpose of this model was to demonstrate the effectiveness of visual prompts as well as a text span editor for medical video Q&A. So coming to the various tools which can be used for prompt engineering, the first tool which can be used is a prompt list. So this is a marketplace wherein the users would sort of build the prompts and they would place it in sort of like a Play Store, and people will be able to buy the prompts and they can also be able to sell the prompts. So few of the models would require specific inputs to be given to obtain specific quality outputs. So this is where we can sort of, if we require the domain expertise prompts, we will be able to go and get that, and also we'll be able to sell our prompts there. And second two important tool would be ChatGPT, as we might have all used. It's a conversational AI, and we can also sort of take a premium account wherein we'll be able to upload our structured and unstructured data, and based on that we will be able to do various analytics and prepare documentations based on that. Third important tool would be OpenPrompt. This is the open source framework wherein we would be able to sort of use the various models which are there, and the various pipelines can be built, as in the layers of various transformer layers can be built. And next one is AIPRM. This is a platform where we can enhance the quality of the prompts which is there. We would have built some prompt and it would enhance and give it in a specific manner so that we would be able to give to the LLM model. And last one is Emergent Mind. This is also a resource for chain of thought reasoning, which includes here we could find various research papers and findings which are there, which are latest research papers can be identified based on our domain to sort of identify the respective papers so that we can give better prompts to the model or identify pre-built models. So coming to the last question, which of the following is a challenge of prompt engineering? So the first one is increasing the computational power needed for simple tasks, ensuring the prompt gives the desired response from the system. Third one is reducing the amount of data needed for processing. Fourth one is decreasing the time it takes to develop the algorithms. So you could answer the whatever your responses in the chat. So I can see that most of you have answered the question. I'll go to the next slide. Few of them are left. So the challenges, sorry. So coming to the various challenges which are involved in prompt engineering, the first challenge is ambiguity and misinterpretation is a challenge wherein we should have an idea what the AI is generating based on the complex prompts which are given, whether it's proper information or it's giving some useless or hallucinating the output. And second challenge would be ethical considerations. We have to design the prompts which align according to the ethical guidelines which is there. And also the bias and fairness is the third challenge. So mitigating the inherent bias, for example, it should not perform racism or something based on certain caste or creed. That should also be ensured. And also the fourth challenge in prompt engineering is adversarial prompts, preventing the prompts that would have harmful outputs or harmful sort of conclusions should also be prevented. And the fifth challenge is model limitations. Working with the constraints of AI capabilities, the model might have been trained on certain data set and it might not be sort of suitable for our data set or input requirement. So we should be able to identify the respective model which suits our requirement. And for our last challenge would be to achieving the desired results. So crafting the prompts creatively sort of helps us to obtain the accurate outputs. So coming to the future directions of where prompt engineering could sort of get integrated in the healthcare sector. So it can be helpful for personalized medicine. As I told initially, the smoking history of the patient was taken to predict the lung disease of the person. So that way we would be able to give personalized medicine based on the features and we would be able to obtain accurate personalized sort of outputs. And next would be to integrate it with IoT. Maybe these variables and IoT devices which are there, we would be able to connect to them and give prompts to them to obtain real-time outputs from them. And also one of our more future direction would be to integrate it with 5G technology so that these outputs would be obtained at a faster rate compared to the previous networking technologies which is there. And coming to the last direction is medical education. For example, we could see that the reports could be tailored to specific user sort of education background or something. So that way we will be able to create a learning pathways or courses for specific students based on their background. So thank you. Yeah. If you have any queries, you can ask. I'll be also giving a small hands-on using tool called as Google Colab, which sort of has Python in its backend and it's open source and sort of easy to use. Okay, I'll sort of show a demo of how you can sort of use prompt engineering. So if you have a Excel dataset or a CSV dataset, so I'll go to Google Colab. So you can type Colab. So this is the environment where Python is installed and you can be able to run various analytics on your Excel or CSV or structured or unstructured data files. So this is what you have to type. You can type Colab Google or Google Colab and you can click on the first link which is there. And later I have created, this is the interface which opens. If you have created previous notebooks, it would show open the previous notebook which is there. And if you have not created, you can click on a new notebook. So you can click on this. So this is the environment which opens. So this is where you can start your coding if you have to write any Python code or if you have to generate any Python code using prompts. And we can see that there is a file wherein we can create new notebooks or save the files which you have created. And there is a folder option. If you have some existing local files in your system, you will be able to sort of upload it. So here is the upload button. So once you click on that, you can go to the folder where your specific data file is there. And you can sort of click open for that. So just a second, I'll upload the data file. So it's in my download. So I'll go here, click on uploads, click on downloads, and then I'd select my dataset, click open. So we can see that ensure that these files are saved, ensure that your files are saved elsewhere. This is just a warning, you can click OK. So we can see that your dataset is uploaded on the right side here. So once that is there are two types of cell, where in text cell you can write for comments and code cell which is there where you can build your Python code for analytics. So here we are going to be using generative AI or prompt engineering to sort of generate the code. So I'll click on this generate button which is there. So and I'll type read a CSV file data. And once you type this, you can click enter. So you can see that it has generated the code which is required to read your data file which is already there. So I'll sort of replace, you have to replace this as given for a generic file and you have to copy the path of your respective file and replace in pd.readcsv. And if you have any doubts regarding how this sort of libraries work, there is also a feature called as, just a second. We can sort of chat with this Colab AI. You can give this respective package name and ask what that package does here. So coming to the code which is generated, I will run that. For running that, you can either click on the run cell option which is there here, or you can press shift enter. So I've done that. You can see here, this was a data set wherein I would show the data set in an Excel file, just a second. So this is the data set which we have, wherein there are multiple columns called as patient ID and his demographics and his type of surgery which he had, and outcome here is the recovery time that he takes, and there are various input features which is there here. So I'll go back to the code here. So here we can see that it has, we can click on show or hide output. So we have read the data set now. Next step would be, in order to see the column names, you can click on a new code cell here and click on generate here, and you can print. You can type here to print column names of df, which is the variable where it's read the data in. So we can see that it's generated the code where we have given the natural language, and the code Python code is generated. So here we can see patient ID, age, gender, and systolic and recovery time, various sort of columns are there. Column names are printed. And if we have to sort of, I can give generate here again. And if we have to see the first 5 rows of the data, we'll be able to sort of generate that also here. So we can see that the head function is printed, a Python function is printed, and it would show the first 5 rows of the data set which is there. So this way we would be able to perform various operations which might include in a data analysis lifecycle. Here I just showed the processing or reading of the CSV file. We would be able to perform various operations which include data cleaning, wherein we would identify the null values or remove outliers or drop duplicates. Once we sort of clean our data, next step would be to transform our data, which can be either through filtering or aggregation or joining or integrating 2 data frames. And once that is done, next step would be to maybe normalize and transform the data so that all of them are same scale. Once that is done, next step would be to build a, if in this case the data set, we can build a regression model wherein independent variables are there, and the dependent variable is the recovery time. And we will be able to give to the generative AI that build a regression model, taking recovery time as the independent variable and other columns, recovery time as dependent variable and other columns as independent variable. So this way we would be able to perform the complete analytics, data analysis life cycle using this Google Colab, and it's free of charge. And we'll also be able to generate the code by giving prompts this way in a natural language, which is English, can be given. So thanks everyone for participation. There is a feedback link which is shared, and you have to sort of share your feedback regarding how the session was, and post that you will be also obtaining the certificate of participation in this webinar. And also whoever has answered quickest, one of them would be getting a t-shirt from our side. That's also there, and we will sort of discuss, share with you that one, and we will contact you. So thanks for the session. If you have any Q&As, you would be able to ask.
So we are ready for the question and answer round. So we have received a question that how prompt engineering is helpful in building EHR.
So initially, in order to build electronic health records, EHRs, prompt engineering can be used to sort of build the basic template of how it should be designed. And after building the design of the EHR, we can also populate it and ask prompt engineering to generate the data set, which is sort of based on the structure that we have designed the EHR. Once that is done, maybe sort of some analytics is needed based on the EHR which we have built. We can also sort of give it, link it to with a prompt or LLM model to sort of obtain the analytic layer also. And those are the possibilities which it can be used for. And also if there is some image or video data which should be stored in the EHR, that's also a possibility. From prompt engineering, it's also possible.
I hope the answer was helpful to Dr. Ritika Malviya. Do we have any further questions? Thank you for your response, Dr. Ritika. So before we announce our winner for the participation here, I would like to announce that we have next webinar on transforming healthcare with IT in AI and data science that is linked with technologies, and it will be conducted on 21st of the May after 4:30. So you will be able to find the link on IIHMR website. So kindly register for the next webinar if you're interested in the given topic. So we have another question from Krishna Bhanushali, that is, what are the other applications of prompt engineering in clinical research?
So one of the thing might be, as I said, generation of these various things is sort of the initial part which it would be performing better. So clinical data generation, according to me, and data augmentation would be the initial phase, since these models are not trained currently on a lot of data. It would be better. Currently the data generation phase is sort of there would be various applications, including the clinical text generation or text augmentation is sort of more possible. And once this models matures and we feed that data to improve our model performance, later on sort of it can be used for machine learning, or deep learning models can also be built for clinical research. And I can also share across with you, Krishna Bhanushali, few of the publications which I have also referred on the clinical side. So that might give you a better idea as to how you can proceed using prompt engineering in clinical research side.
So we have next question, how to start career in prompt engineering as a fresher?
So one of the things which you can sort of do is that you can sort of enroll for a master's. So that sort of course teaches you the back end of how it works. So you will also learn the domain expertise in healthcare, and also sort of how you can sort of build one of those LLMs. So for example, ChatGPT Premium is there, which sort of is paid version, and it sort of you will be able to customizely build your own GPTs. So that's also part of a learning, or you can sort of explore how that is possible. So that's the way you can sort of start using them, and also sort of explore the prompt base which is there to sort of understand how the prompts would be more effective, and ratings are also there, which would sort of give a better idea. And our course is also there, PGDM in AI and data science, which you can sort of enroll, and you will be getting more insights once you sort of join us, and we will be there to sort of guide you in a better manner.
Do we have any further questions? I would also request everybody, all the participants, please fill the feedback form so that you can receive your participation certificate subsequently. Kindly fill the feedback form. We'd like to announce the winner for the quiz competition. We have one winner here, Mr. Abhishek V.
Okay, I would like to congratulate
Congratulations
for answering it the proper answer in a faster time.
Mr. Abhishek, you are requested to kindly contact the admin department for your prize. Many congratulations, Abhishek. Also, IIHMR Bangalore's admin department will be contacting you, Abhishek, for the prize. So I guess that is all. Thank you everyone for joining. Please fill the feedback form so that you can receive your certificate.
Thank you everyone for joining.